Dr. Kirk Haas. I'm an associate professor in the Department of Cellular and Physiological Sciences, and I run a research lab in the Brain Research Center at UBC. Yeah, I did an undergraduate in neuroscience at Cornell University in New York. I did a PhD at the Albert Einstein College of Medicine in the Bronx, and then I did a postdoctoral fellowship at Cold Spring Harbor Laboratories. When I came to Canada to establish my lab, I was seeking funding to start an innovative program to develop new technologies, and it was very challenging to get funding for such things. So my colleagues, other new investigators in the area had received funding from the Scottish Rite, so I applied for the funding. They were one of my first funding sources. They were very critical for getting my lab started. Allowed me to hire people and to investigate new avenues that probably wouldn't be funded through traditional government funding schemes. It's a very exciting time to be a neuroscientist. We're developing a lot of new tools to directly image activity in the brain and to trace neural circuitry and look at real brain neuron morphologies. And a lot of this is happening within the intact brain. And we're finally being close to understanding how brain circuits are formed and how they function, but there's a lot left unknown. What's the basis for consciousness, where memory is stored, these sort of questions. But understanding these fundamental questions will give us insights to both how normal brains work and how diseases arise. Neuroplasticity refers to the way that the brain changes in response to the environment. And I'm interested in how the developing brain develops, how you get a very complex brain circuit, how you get a very functional brain circuit, and the role that activity, environmental stimulation, helps to direct that circuit formation. And that there's sort of environmentally induced changes is what we term plasticity. And we think there's an interplay between our genes and the environment for sculpting our brain circuits. And we think that this very early stage of brain circuit development is when neurodevelopmental disorders occur, such as autism and epilepsy and schizophrenia. So we're seeking the fundamental mechanisms and how those mechanisms can go wrong to cause disease. One of the major projects I was funded for through the Scottish Rites was to look at the effects of seizures during early development on brain circuit formation. Unfortunately, seizures are quite common in newborns, and that's precisely the stages when their brain circuits are forming. And this seizures are abnormal synchronous activity throughout the brain, and we're very interested in the role of environmental stimulation driving activity, helping to sculpt normal brain formation. So we were wondering whether abnormal seizure activity interferes with those normal processes. We found by directly watching brain neurons grow during seizures in developing brains, we found that indeed they did have a strong impact, and they hijack the normal mechanisms that are involved with learning and memory and environmental driven brain formation to cause abnormal structural formations that we think cause brain circuit dysfunction later in life. It's a huge economic and emotional burden. The cost for autism itself is staggering. It's on the order of billions of dollars, and it's ever increasing. These costs are doubling every 5 years or so. So it's a significant impact on our society. And that's just the economic cost. There's a tremendous social and emotional cost, of course, to all the families involved. So it's one of the most important areas of research in neuroscience today. I very much appreciate what they've done for me, and I can see what they've done for other growing laboratories. And I think that it's a great opportunity to seed these growing professions, these growing careers for early career stage scientists. And they're allowing people to start new programs that over 5, 10 years or more develop into very large research programs that have significant impact on these questions. I'd very much like to thank the Scottish Rite Charitable Foundation for their generous support, which was very significant in our ability to build our successful lab.